Hello friends, I am Rathod welcoming you in the solution session of assignment 4.2, which is based on adjoint and inverse of matrix. So without wasting time, let's get some fun to solve examples. We have to find adjoint of matrix n, and for that we are going to need our predefined format, and here it is, our adjoint with space of respective cofactors. So without wasting time, let's fill them. Our first cofactor, which is at a11, will have positive sign, and to get its determinant we need to ignore first row first column. So here we'll get 0 1 4 3. Then the cofactor of next element, which is at a12 position, will have negative sign. We have to ignore first row second column. So here we'll get 1 1 4 3. Then cofactor of a13 will have positive sign, and after ignoring first row third column, get 1 0 and 4 4. So here we complete our cofactors of first row. Now let's move to the second row's first column, which will have negative sign, and its determinant will be -3 and 4 3. Similarly, let's move to next element. Positive sign and determinant will be -4 -3 and 4 3. And similarly, the last element of the second row cofactor will have negative sign and -4 -3 and 4 4. So here we complete our second row's cofactor. Now let's move to the last row first column. Its cofactor have positive sign and -3 0 1 determinant, and next element cofactor will have negative sign and its determinant will be -4 -3 1 1. The last element, which is in third row third column, its cofactor will have positive sign and elements are -4 -3 1 0. Now we just have to simplify and take a transpose to get our adjoint. So let's start to simplify. Our first element will be 0 3s are 0, then -4 1s are 4 will give us -4. Then next element 3 -4 will be -1, and this negative sign will convert into +1. Similarly, next element 4 1s are 4 -4 0s are 0 will give us +4. Now the first element of the second row, -3 3s are -9 -4 -3s are -12 will give us -3, right? Okay. And the middle element -4 12 these are -12 -4 -3s are -12, which will give us nothing but 0. Then -16 -12 with the negative sign will give us 4. The first element of last column, -3 -0 will give us -3, and -4 -3 will give us 1, and the last element will be 0 -3, so it will be +3. Okay, just take a transpose and you will get your answer. -4 1 4, which is your first row, will become your first column. Similarly, second column will be -3 0 4, Last column will be minus 3, 1, 3. Tada! This is your actual matrix, and so option A is your final answer. Here we have to find adjoint of matrix 1, 0, 0, 5, 2, 0, minus 1, 6, 1. And to get the adjoint, let's get our predefined format first. And here it is. Now we just need to get the cofactor for respective their places. And for that, the sign is already allotted. We just need to get their minors, right? So first determinant, which is actually cofactor of first row, first column element, is obtained by ignoring its row and column, or we can say first row, first column. So here we will get 2, 0, 6, 1. Okay, now let's move to the second determinant, which is cofactor of 0, which is placed at first row, second column. So here we have to ignore first row and second column. So we will get 5, 0 and minus 1, 1. Now the next element, which is at A13, is 0, and to get its cofactor, we need to ignore first row and third column. So here we'll get 5, 2, minus 1, 6. So here we complete our first row's elements. Now let's get to the second row. First element, cofactor of 5 by ignoring first column and second row. So here we'll get 0, 0 and 6, 1. Now next element is 2, and we have to ignore second row, second column. So here we'll get 1, 0 and minus 1, 1. And now last element of the second row should be selected, and its cofactor will be formed by ignoring second row and third column. So here we'll get 1, 0 and minus 1, 6. So we successfully complete our second row's elements. Now we should move to the third row. First element, which is in third row, first column, then its cofactor will be 0, 0 and 2, 0. Then next element is 6, and its cofactor is 1, 0, 5, 0. And finally, for the last element, we have to ignore third row, third column. We will get 1, 0 and 5, 2. Now we just have to simplify. 2 1s are 2, minus 6 zeros are 6. So here we will get plus 2. Then 5 into 1 will be 5, and minus 1 into 0 will be 0. So here we will get minus 5. And finally, the last element of the first row, 5 6 are 30, and minus 2 will give us plus 2. So it will be 32. Similarly, we can get our second row. Here we'll get 0, then 1 and 0, so 1, and the last element will be 6 and 0, or we can say minus 6. Last elements are 0, 0 and 2. So your answer is not A. Don't forget to take transpose. So your first row, which is 2 minus 532, will be your first column. Then second row will become your second column, and last row become your last column. So your correct answer is 200 minus 510, 32 minus 6 and 2, which is none of these options. Tada! We need to find adjoint of given matrix. For that, we are going to need our predefined format. Here it is with the space of respective cofactors. The cofactor of first element will have positive sign, and we have to ignore first row, first column. So here we'll get 2 minus 3, minus 1, 3. Then the cofactor of next element will have negative sign. We have to ignore first row and second column. So here we'll get 1 minus 3, 2, 3. Similarly, the cofactor of last element is plus 1, 2, 2 minus 1. Now let's move to the second row's first element. Its cofactor have negative sign and elements are 1, 1, minus 1, 3. Rest of the two cofactors can be found similar way. We have to select element at A22 and ignore second row, second column. We'll get 1, 1, 2, 3. Then the last element of the second row should be selected and its cofactor will be minus 1, 1, 2 minus 1. Then the cofactor of last column's first element is plus 1, 1, 2 minus 3, and the next one will have minus 1, 1 and 1 minus 3. The last cofactor is 1, 1, 1, 2. Now just simplify for the next step. 3 2s are 6 minus 1 minus 3s are 3, which will give us 3. Now the next element, 3 1s are 3 minus 2 minus 3s are minus 6, will give us plus 9, but with the negative sign it will be minus 9. Similarly, the next element, minus 1 minus 4 give us minus 5. So let's write down minus 5. The first element of the second row, 3 minus 1 will give us plus 4, but with negative sign it will be minus 4. Next, 3 minus 2 will give us 1. And last element of first row, minus 1 minus plus 2. So it will be minus 3, but with negative sign get plus 3. First element of last row will give us minus 3 minus 2. So it will be minus 5. Next one, minus 3 minus 1, which will give us minus 4, but with negative sign we will get plus 4. Last element, 2 minus 1 will give us plus 1. And don't forget to transpose. So your first row become your first column. 3 minus 9 minus 5 minus 4 1 3 will be your second column, and minus 5 4 1 will be your third column. Option B is your final answer. Ta-da! It's A. And for that we are going to need a predefined format, and here it is. Now let's start filling the empty determinants. First element's cofactor will be obtained by ignoring first row, first column. So here we'll get 1 2 0 1. Then the next cofactor will be obtained minus 0 2 2 1. Similarly, last cofactor of first row is 0 1 2 0. Now the first element of second row will have minus in their cofactor, and you have to ignore its second row and first column. So we will get minus 2 0 and 0 1. Now it's time for cofactor of element A22. It will have positive sign, and we have to ignore second row, second column. So here we'll get 1 0 2 and 1. Similarly, cofactor of last element of the second row will be 1, 2, 2, 0. Then next cofactor is 2, 0, 1, 2, then minus 1, 0 and 0, 2, and the last one is 1, 2, 0, 1. So here we complete our first step. Now in second step we have to simplify. So let's multiply and simplify. 1 minus 0 with positive sign will give us 1. Now the next element 0 minus 4 will give us minus 4, but with negative sign we will get plus 4. Then 0 minus 2 will give us minus 2. Now we should move to the second row. 2 minus 0 with negative sign will give us minus 2. 1 minus 0 with positive sign will give us 1, and 0 minus 4 will give us minus 4, but with negative sign we get plus 4. Similarly, the elements of third row are 4, minus 2 and 1 respectively, but don't forget to get transpose. Your first row will become your first column, then second column minus 1, 2, 4, which is your second row. The last column minus 2, 1. Tada! Option B is your final answer. In this question we have to find adjoint of matrix A, and for that here we have our predefined format. Now fatafat, let's find out the cofactor of respective terms. The cofactor of first element is minus 3, 4, minus 1, 1. Then the next element's cofactor will have negative sign 2, 4, 0, 1, and the last cofactor of first row will be 2 minus 3, 0 minus 1. Similarly, we can get the cofactor of first element of second row, ignoring second row first column. So here we'll get minus 3, 4, then minus 1, 1. Now the next element which is in second row second column, so here we have to put plus sign, then 3, 4 and 0, 1. Okay, now let's move to the next element. Its cofactor will have negative sign and 3 minus 3, 0 minus 1. Now we should move to the third column. Its first cofactor is minus 3, 4, minus 3, 4. Then the cofactor of next term will have negative sign and 4 and 2, 4. And the last cofactor is 3 minus 3, 2 minus 3. Now it's time to step number 2. Simplify. 1 minus 3 is minus 3, minus minus 1 4 is minus 4 will give us 1. Then next element is 2 minus 0 with negative sign, we get minus 2. Last element of the first row minus 2 minus 0, so here we get minus 2. Next element is minus 3 minus minus 4 will give us 1, but with negative sign it will be minus 1. Then 3 minus 0 will give us 3. Next minus 3 minus 0 with negative sign, get plus 3. and elements of the last column is 0, -4 and -3. Last, don't forget to transpose. So first column will be 1 -2 -2. Second column will be -1 3 3. Last column will be 0 -4 -3. Tada! Option B is your final answer. In this question, we have to find inverse of matrix A, and for that we are going to need determinant of A and adjoint of A. So first of all, let's find out determinant of A by multiplying B with A, gives AB, minus D with C, will give us CD. Now the next term, which is adjoint of A, which is simple for 2 cross 2. We just need to exchange the position of principal diagonal element. So instead of A, we have to write down B. Instead of B, we have to write down A. And multiply negative sign to the rest of the term. So here we'll get minus C and here we will get minus D. Okay, so here we get adjacent also. So we can easily find out inverse of A, which is 1 upon determinant of A into adjoint of A. Determinant of A is AB minus CD and adjoint of A is B minus C minus DA. So tada! Option A is your final answer. So matrix A 3 2 1, and for that our first step is to get the value of determinant. It is obtained by multiplying 4 with 3 is 12 minus 1 with 2 is 2. So it will be 10. Now it's time to get adjoint of A. And we all know that adjoint of A of 2 cross 2 can easily obtain by interchanging principal diagonal elements. So instead of 3, we have to write down 4, and instead of 4, we have to write down 3. And simply multiply negative sign to the rest of the term. So here we'll get minus 2 and minus 1. Okay, so we are ready to get the value of A inverse, which is 1 upon determinant of A into adjoint of A. Determinant of A is 10 and adjoint of A is 4 minus 2 minus 1 3. Tada! This is your A inverse. Now here we have one interesting question. We have to find element in first row and third column of inverse of matrix A. So here we have to find A first row and third column in inverse of matrix. Don't worry, આપણે આખો A inverse find કરવાની જરૂર છે. Just એક જ element find કરવો હોય તો હું જે steps શીખવાડું એને follow કરજો. Your step number 1 is find out determinant of A. Actually matrix A is upper triangular matrix. So its determinant is simply product of elements of principal diagonal 1 into 1 into 1. So its determinant will be 1. The second step is to take transpose of matrix. So 1 2 minus 3, which is your first row, will become your first column. Then second column will be 0 1 2 and third column will be 0 0 1. Now to find inverse matrix A13, we need to get cofactor of A13 in A transpose. So to get cofactor, we need to select A13 element. Its sign will be positive from the symbolic determinant format. So let's get plus, and to get this 2 cross 2 determinant, you have to ignore its row. We can say first row its column, which is third column. So here we'll get 2 1 and minus 3 2. Now just cross multiply. 2 2s are 4 minus 3 1s are minus 3. Okay, plus 7. Now it's time for the third step. A13 of inverse is equal to cofactor of A13 in the transpose matrix upon determinant of A. So here we will get 7 upon 1, or we can say 7 is your final answer. Option D is the final option. Ta-da! In this question, we have matrix A of order 3 cross 3. So let's write down n is equal to 3. And A inverse is 1 upon K adjoint of A. We have to find this A. No problem. Let's compare this condition with formula of A inverse, and you will notice that where K is nothing but determinant of A. So to get the value of K, we have to find determinant of A. And here we have our determinant. Let's expand with respect to first row. So the elements of the first row 3, then minus 2, its space of determinant, plus 4, space of determinant. Our first determinant is filled by 2 minus 1 and 1 1. Then the next one will be 1 minus 1 and 0 1. Finally, the last determinant will be 1 2 0 1. Okay, so we are ready to simplify. Here 1 2s are 2 minus 1 minus 1s are minus 1. Then minus 2 will be as it is. 1 1s are 1 minus 0 minus 0s are 0 minus 1s are 0, plus 4 will as it is, and 1 minus 0. Simplifying this, we will get determinant of A is equal to 11, or we can say K is equal to 11. Ta-da! Option D is your final answer. This question we have K is a scalar number and I is a unit matrix of order 3. So let's write down n is equal to 3. Then we have to find adjoint of Ki. So here we are going to use the ninth property. Adjoint of Ki is actually rewrite as K raised to n minus 1 into adjoint of I. Right? Okay. Now here n is 3. So let's write down K raised to 3 minus 1, or we can say 2. Adjoint of I is I itself. So tada! Option D is your final answer. Let's see our next question. If the value of third order determinant is 11. So here we have one determinant, let's call it A, and its value is 11. And the order is 3. Then the value of square of the determinant formed by the cofactor will be. Okay. So before we go for the square, first of all, we have to determine determinant formed by the cofactor, and it's actually determinant of adjoint of A. And we all know that determinant of adjoint of A is nothing but determinant whole raised to n minus 1. And here n is 3. So we can say here we have to write 3 minus 1, or we can say square. So our delta is 11 square, or we can say 121. But don't forget, we have to find square of determinant formed by the cofactor. Actually we have to find delta square. So 121 square, which is equal to 14641. So tada! Option D is your final answer. We have one formula based small question that if T is a determinant of 0, 0, 0, 2, 0 and 0, 0, 2, then determinant of adjoint of P will be. Here we are not going to find the adjoint and then instead of that we just use the formula, or we can say one property of adjoint, that adjoint of A is equal to determinant of A raised to n minus 1, where n is the order of A. Here the order of P is 3, right? So we can say n is equal to 3. Now simply use the formula. So we can say determinant of adjoint of P is nothing but determinant of P raised to 3 minus 1, or we can say P raised to 2. So D is the correct option. Ta-da! In this question, we have matrix A, which is a singular matrix. Therefore, we can say determinant of A is 0. And we have to find the value of A into adjoint of A. And for that, we have to use the first property, which is A into adjoint of A is nothing but determinant of A into I. Actually, determinant of A is 0. So, 0 into I will give us null matrix, or we can say O matrix. So, A is the final answer. Ta-da! In this question, we have matrix A with the order of 3 cross 3 and B is the adjoint of matrix A. So let's write down the order of A is 3 and adjoint of A is equal to B. Okay, now we have the determinant of B, which is equal to 64. We have to find determinant of A. And for that, we have to take determinant on both the sides. For left hand side, we are going to use the third property, which represent determinant of adjoint of A is nothing but determinant of A raised to n minus 1. In our case, determinant of A raised to 3 minus 1, or we can say square, is equal to determinant of B. Now we already know the value of determinant of B, which is 64. So we can say determinant of A is equal to root of 64, or we can 8. Ta-da! Option C is your final answer. Here we have one matrix A and A inverse is exist for matrix A, and for that the necessary condition is determinant of A should not equal to 0. So let's use this condition to get the proper answer. Let's find out determinant of A, and for that you have to expand with respect to first row. So the elements of the first row, 2 determinant minus lambda determinant plus minus 3 and its determinant. Now to fill first determinant, you have to ignore first row, first column. It's 2, 5, 1, 3. Then next determinant is obtained by ignoring first row and second column. So it will give us 0, 5, 1, 3. Finally, the last determinant will be 0, 2, 1, 1. Now we just have to simplify. 2 will be as it is, then 3 2s are 6 minus 1 5s are 5, then minus lambda will as it is, 3 zeros are 0 minus 5, and minus 3 will as it is, 0 minus 2. Here we will get 2 plus 5 lambda plus 6, which is your determinant of A. Now, we know that determinant of A is not equal to 0. So, we can say 5 lambda is not equal to minus 8. Or we can say lambda is not equal to minus 8 by 5. Then and then A inverse can be exist, right? Which suggests that option D is the correct option. Ta-da! Let's see the next question. If A is the given matrix and its determinant is 6 and adjoint of A is given by this matrix, then we have to find the value of K. Adjoint of A matrix contain K, right? So here we should find out the determinant of adjoint of A. Here it is. Let's expand with respect to first row. So the elements of first row is 1 and its determinant, minus 2 and its determinant, and finally plus 4 and its determinant. Now let's fill the first determinant by ignoring first row, first column will give us 1 1 and K0. Next one will be 4 1 and minus 1 0. Similarly, the last one will be 4 1 and minus 1 K. Simplify it. 0 1s are 0, then minus K, and minus minus become plus 2. Here 0 4s are 0, minus 1 1s are minus 1, and plus 4 will as it is. Here we'll get 4K minus 1. So we can further simplify it in minus K, then plus 2 plus 16K and plus 4, which is your determinant of adjoint of A, right? Okay. Now from the third property we can say determinant of adjoint of A is nothing but determinant of A raised to n minus 1, where n is the order of matrix. Here n is 3. So we can say determinant of adjoint of A is determinant of A the whole square is equal to, we have 15K plus 6, and we already have the determinant of A which is 6. So 6 square will be 36 is equal to 15K plus 6, which will give us K is equal to 2. Ta-da! Option C is your final answer. In this question, we have matrix A which is equal to cos alpha sin alpha minus sin alpha cos alpha, and A into adjoint of A is K0 0K. Then we have to find K. No problem. First of all, from the first property, let's find out A into adjoint of A, which is equal to determinant of A into I2 in this case. So our determinant will be cos alpha sin alpha minus sin alpha cos alpha into matrix I2, which is 1 0 0 1, right? Okay. Now simplify the determinant, cross multiply cos alpha with cos alpha will give us cos square alpha, then minus sin alpha into sin alpha will give us minus sin square alpha, right? And I2 will be as it is. Okay. Here cos square alpha plus sin square alpha give us 1. You can say we get 1 0 0 1 as a right hand side. Now in question it is given that A into adjoint of A is nothing but K0 0K. So let's compare the matrix and we will get K is equal to 1. Ta-da! Option B is your final answer. In this question we have A as a non-singular matrix of order 3. So let's write down n is equal to 3. Then we have to find adjoint of A, and for that we have to use the fourth property of the adjoint. So let's write down the property, which is adjoint of A is nothing but determinant of A raised to n minus 2 into A. In our case n is 3, so simply we will get determinant of A into A. Ta-da! Option D is your final answer. In this question we have matrix A of order 3 cross 3. So let's write down our and it's 3. We have to find determinant of adjoint of A. We are going to use the third property in which we are going to need the determinant of A. So first of all, let's find out determinant of A. So here we have our determinant. Let's expand with respect to first row. So its first element 1 and space of determinant minus second element 2 its space of determinant plus 3 and its space of determinant. Now for first determinant we have to ignore first row first column. So here we'll get 4 9 and 8 27. Then for the next determinant we have to ignore first row second column. So 1 9 and 127. Finally for last determinant we have to ignore first row and last column. So here we'll get 1 4 1 8. Right, now we just have to cross multiply. 1 will as it is, 27 4s are 108 minus 8 9s are 72. Then minus 2 will as it is, here 27 1s are 27 minus 1 9s are 9. Finally plus 3 will as it is, and 8 1s are 8 minus 1 4s are 4. Just simplify. We'll get determinant of A is equal to 12. But don't forget, we have to find determinant of adjoint of A, which is actually determinant of A whole raised to n minus 1. We already find the determinant of A, which is 12, and n is 3. So 3 minus 1 will be 2. So your final answer is 12 square, or we can say 144. Ta-da! Option C is your final answer.